Now we discuss about that alcohol. Alcohol is a functional group which is a part of the family of the organic compound. Okay. Means like for example is alcohol you have any carbon chain. Okay. In that carbon chain if you attach that which group. Okay. So this carbon chain is completely depends on the group functional group which is attached with that. Okay. So this OH group is represent as the alcohol.
Yeah.
So for example, how this alcohol is allowed to form and what kind of the applications they have. Primarily in alcohol we consider as in general single carbon chain we will consider as a meth, double carbon chain we are consider as eth. Okay. So that is terminology we are using. Okay. Same as most commonly the alcohol which is most probably used in general application we are considered as a ethanol. Okay. Means which have two carbon chain plus alcohol group. Okay. So for that the naming will consider as a this one is considered as a thiol plus alcohol on. Okay. So it will consider as a ethanol. Okay. You get it? This one part?
Yeah. Mm-hmm.
So in that
Understand?
case, we are considered as a ethanol is the alcohol which is formed by the first we discuss about the fermentation part, and the next we are just considered as a discuss only by the good products. Okay. Primarily, if we discuss about it, alcohol which is obtained can contain the OH group and generally is considered a chemical. This OH group is responsible for the any chemical and nature which is take a part in reaction. All the chemical properties depends on the OH group. So naming will consider as a first we name the naming of the alkyne chain what we are considering. Then we are using one suffix that is represented by the ol. Okay. If it is chain is methane means single carbon. So here it is allowed to remove one hydrogen and attach with the OH group. So that will term as methanol. Okay. If it is like ethane 2 carbon, so ethane plus all it will get converted into ethanol. Hmm. Then generally this is a like any kind of if we are 3 carbon, so this chain will consider as a propanol. Okay.
Yeah. Mm-hmm.
So NL considers in general applications how this consider methanol have the general applications. Okay. Most commonly the methanol is used as a feedstock, means like a starting material for the other chemical reaction. Okay. And also they are useful for the anti-freezing agent. Okay, because they are not get easily get completely solidify at a normal cooling temperature. Okay, so they are using as an anti-freezing agent and is in the production of the biodiesels. Okay, which is a completely environmental friendly for petroleum products. Okay, so in that case, and a general application will consider as it is sometimes ethanol is work as a very good solvent and very useful fuel in industrial requirement. Okay, that is the general applications we have with that phenol and methanol. Now we'll discuss about a little bit of the physical properties for the alcohols. Alcohols, like for example, if we consider the ethanol and the methanol, because of they have a very short of the carbon chain because methanol have only one carbon chain and the ethanol have two carbon chain. Okay. Due to that, they both having very low boiling point.
Yeah. Mm-hmm.
So it will get easily get broken down. So that is considered as due to the very weak interaction between that particles, so they are easily get overcome, and when we'll consider as the alcohol chain become larger, means more than two carbons get attached, like means it is considered as like you have a 5 carbon chain pentanol and the more than hexanol, that chain will get size get increases, their high boiling point values also get increases. So that's the first property of the alcohol, that is represented by the boiling point. As and the boiling point is get higher for the corresponding alcohol, generally if you are considered as compared with the methane and the methanol. Okay, so in that case methane have low boiling point as corresponding their methanol. Okay, means we had a sequence in which if you are comparing between the, suppose you are comparing between the three things, one is methanol, one is methane, and one is ethanol. Okay, so primarily only the same number of carbon chain which having the all group and which is not having the all group. So this one having the higher boiling point as compared to this one. Means first less boiling point is methane, second one is have a little bit higher than of as compared to methane, and the most higher than in both of that will be considered as a ethane. Okay, if you have a single carbon chain and you're comparing with the same number of carbon with the all group, it's have a more boiling point. Okay, compared to this one. But as number of carbon chain is increases in that one ratio, that one having more as compared to this one. Okay?
Yeah. Mm-hmm.
That's the property this alcohol have, that is considered as a solubility. And considered as alcohol in the short-term compounds, means are the short-chain alcohols like methanol, ethanol, because they have the very short carbon chain, so they are very easily soluble in water due to presence of the OH group in that chain. Okay, so that's why they are making a very strong interaction between the with the water molecules. Okay, so with ethanol, methanol is wrapped up very easily get soluble, but as much as we are considered as a carbon chain is get increased, means you have a very long carbon chain in the alcohol, so their solubility in the water same as their boiling point gets increases due to the chain size get increases, same as their solubility also get decreases as the chain size get increases. That means longer chain is become less soluble in the water and this tends to be allowed to float on the top surface of the water. Okay, so both properties is directly depends on the size of the chain. If we'll consider as a boiling point, if chain size is higher, so boiling point is also high. And for the solubility, if chain size is higher,
Yeah. Mm-hmm.
so the solubility is decreases in the water. Okay, due to that, because the organic compounds size get increases, organic compounds are continue to not have the ion condition, so they are not get ionized, so they are not get soluble in the polar solvent, and the water is the polar solvent. Okay, and they become non-polar in nature, so that's why they're not allowed to get dissolved in water. We'll discuss about that how the alcohol having general applications we are using. Okay, on the basis of how it's perform the different chemical reactions. Primary reactions we discuss about the alcohol is used as a fuel. Okay, alcohol is a very good fuel because, as you know, all the petroleum sources are related to the hydrocarbon chain, and the alcohol, due to the presence of the hydrocarbon chain, its work as a very good fuel. Okay, and once it can burn in the air, in the good supply of air, they are allowed to form carbon dioxide and the water, like just perform in the combustion reaction. Any carbon chain, or like organic compound or any fuel, if you burning in the presence of oxygen, they will allow to convert into CO2 and the water. Okay. Under the same combustion reaction, ethanol, if you burn it in the presence sufficient amount of oxygen, we are allowed to perform the complete combustion reaction, and the product you will get CO2 and the water. Okay. So the ethanol, which is used to for the like as a petroleum source, is termed as a bioethanol. Okay, because this production of the bioethanol is help us to reduce our dependence on the fossil fuels, because the fossil fuels are non-renewable resources for us. Okay, so as much as the quantities get decreases, so it's create a very big problem in front of us. So as we use getting the some alternative sources like as a bioethanol, so it's reduce our dependency on the fossil fuels. Now we'll discuss about that how this ethanol is get produced. Okay, first, most common and in the wide range, we are using one technique that is called as fermentation. Okay, in fermentation, in simple form, we can say this is like a anaerobic respiration reaction, anaerobic reaction in which you are converting any complex substances in the presence of microorganisms, you are converting into the simple one unit. Okay,
Yeah. Mm-hmm.
and general process of fermentation is called as the anaerobic process, in which we are considered as we are taking the complex unit which is get decomposed in the presence of microorganisms and convert into the simple molecules. Okay, that is termed as fermentation. Ethanol in wide range is processed and formed by the fermentation. Okay, in the fermentation, what we are taking, we are using the sugars. For example, sugar source we can use the barley, okay, grain, okay, and this sugar is kept decomposed by the yeast, okay, in which most commonly yeast we are using, that is called as Saccharomyces cerevisiae, okay, and that yeast is used as an energy source for the anaerobic respiration. This yeast is allowed to get decompose this sugar, okay, and this sugar get decomposed. When it's decomposed by the this microorganism, it is allowed to get break into ethanol and the carbon dioxide. Same as if your reaction, it can represent it, you can represent it like this. Here you have one glucose molecule in the presence of yeast, and the providing the sufficient condition, it will get break into two molecule of ethanol and two molecule of CO2 get released. Okay, this is the general fermentation process is represented. Okay.
Yeah.
The journal condition what we need to perform this fermentation reaction rapidly, and you getting the very good quantity of the ethanol to be produced by the decomposition of the sugar. Okay. Primarily, this reaction is get speed up by the using the enzymes. Okay.
Yeah.
Because these enzymes work as a biocatalyst to speed up the reaction. Okay, most commonly like Siamese enzyme we are applying. Okay, this is allowed to boost up the speed of the reaction, and it's need optimum conditions in which temperature and the pH should be maintained. Okay, temperature range approximately it's 37 degrees Celsius. Okay, or any lower reactions get slow, but at the higher temperature. If your temperatures become higher, so the enzyme which you are adding to speed up the reaction, it get denatured. Okay, because the enzymes reactions, the catalyst reactions are very specific for each and every reaction. Catalysts are very specific in nature. Okay, so as the optimum condition get changed, the active site, the shape of the active site of that enzyme, it will get also changed. Okay, that's why temperature control is must for the fermentation reaction. Okay. Next one, the property we need to be maintained. That one is the optimum pH. pH we are significantly we are not considered as a not higher and not lower so much. We are maintain the optimum pH condition. Okay, not so much higher, not so much lower, because if your pH becomes so much high in basicity and the pH become too much low, is considered highly acidic condition. So it will allow to prevent the active site, okay, to work properly. Okay, that's why pH range we need to be maintained around 4 to 6. Okay, not so much high pH, not so much low pH we need to be change, because if we change the pH value so much up to down, so it will change the active site of the enzyme. So the enzyme which is not working properly, the reaction speed become too slow, and the process will not run properly. If once the ethanol concentrations get level, okay, means this is allowed to start to get killed as yeast, because once the concentrations get achieved, so the yeast get completely degenerated and the concentration as well increases. So further to get the purity form of ethanol, we using the process of distillation. Okay, in which we are considered as making the spirit of the like whiskey and any kind of the alcoholic product we can make. Okay, in the distillation technique is based on like once you are making any object, okay, any product, so if any impurities it is present in that, we are having a difference in the boiling points. Okay, so on the basis of different boiling point, you can separate the impurity part from the pure resin. Okay, in that case the distillation
Yeah.
we are need to be applied. That is the first technique, the fermentation. Now we discuss the second process, how this ethanol can be used by the using the biotechnology. Okay, in biotechnology we are using some genetically modified bacteria, E. coli, okay, which is having ability to convert the waste biomass, the waste material, okay, and that biomass material, when it's considered like that plants in the body, the waste biomass is get converted into the useful ethanol, in which we are considered as like a maize stalk, wood waste, like this kind the waste we are collecting and providing the optimum condition to the high level of the bacterial growth on that, and once the bacterial get grow in the presence of optimum condition, they are get denaturate this kind of the maize chalk or the wood paste and allowed to convert into the ethanol. Okay. Once the bacteria reach the optimum condition, liquids get run at the higher temperature in the presence of the phosphoric acid as a catalyst. Okay. So once we'll get in that one, so they are allowed to get converted any unreacted ethylene as get recycled. Like suppose for example, same this biomass after the action of E. coli, it will get allowed to get convert into ethanol, and if some mass of the ethanol is not convert, is not some unreacted part of ethene is left it, so again ethene and steam means ethene like formula is CH2 double bond CH2. Okay, this one react with the steam means the water instead was formed. Okay. So once it will get react with that, both get react to each other and allowed to convert into ethanol, CH3, CH2, OH. Okay, so means for this kind of process, there is no any kind of the waste is allowed to produce. The total process is get recycled again and again until the total your input reactant part is not get converted into the product. Okay, so we are not getting any kind of waste, so that is the most level this advantage we have. We are not having any kind of the waste for the production of the ethanol.